Hey, hello, and welcome everyone. Thank you so much for joining us today. We're really excited to have you here. My name is Rebecca, and I work on the content team here at GitLab. And before we get started, I'm just going to go over a couple of housekeeping items. If you haven't joined us for a webcast before, you'll know what to expect after this. So feel free to ask questions throughout the presentation. You should see a Q&A box at the bottom of your screen, which you can use to send in your questions. We will have some dedicated time for those at the end of the presentation, but you can go ahead and send them in as soon as you think of them. And if you're experiencing any technical difficulties, there is a chat function on the side, which you can use to get in touch with one of us who should be able to help you. Please do keep any questions related to the presentation to the Q&A box, though, because that just helps us make sure that we do get to address all of those before the end. And lastly, we will send the recording to you afterwards. So if you need to drop out early, you won't miss anything, and you can always review things at your leisure afterwards. So we have two speakers on today. Joel, who is one of our solutions architects, will be doing most of the presentation. But we've also got Josh, one of our product managers, on hand to answer your questions. And as you can see from the agenda, there's a lot to cover today, so I won't keep you any longer. I'm going to hand over to you, Joel.
Okay, thank you, Rebecca. I appreciate it, and thanks to everybody for joining us today. Let's jump right in. First and foremost, this quote, I think you've probably seen it over and over. Can you believe this was more than 6 years ago already, though? Notice August 2011. You know, Mark was spot on when he said these words, and we've seen a ton of industry disruption since 2011, and not just from Silicon Valley, which was what he was focused on at the time. Whether or not you consider yourself to be in that business of software, you are. Virtually every product and service today contains a digital element, and some component of your user experience will absolutely be online. Since this statement was originally made, we've seen major banks become primarily technology companies. We've watched cars start to drive themselves. We've witnessed the birth of the automated home with Alexa and Nest and all those good things, Wi-Fi outlets, right? Let me take this one step further. I'll make the prediction that your business is going to be fully cloud native and fully web interactive with your end users over the next 2 to 3 years. The discussions we're having, especially as they relate to things like the cloud and Kubernetes, they're going to force you to move faster and faster, especially within that environment. But let's take the conversation one step further. You know, when we talk about disruption, we talk about change, software is oftentimes been relegated to a manufacturing discussion, but it's not limited to manufacturing. You know, we're used to seeing the pictures of the robots on the assembly line building cars. But what about things like fintech, financial technologies? 61% of financial services jobs are expected to be replaced by software over the next 10 to 15 years. The unbundling of services that banks provide, it's led to completely new industries overnight. Companies like M1 Finance and Stash, they've made a large dent in the financial services industry, and they came out of nowhere. It was 2015 that each of those companies really came on the scene. Every sort of job has the potential to be consumed by software, whether it's robo-advisors, truck drivers, grocery stockers, cashiers. You know, what's the robot in this picture doing? Is it taking inventory? Is it shopping for you? Is it stocking shelves? Does it matter? It's eating jobs. And if you go to this store and Amazon owns it, there's no cashier either. You literally just walk out the door and you've paid for everything. So take the statement Mark made and now compare it to what was said earlier this year by the NVIDIA CEO. Back in May, he said, software is eating the world, but AI is eating software. So it's putting a new software development issue in play just to stay competitive. And I think we're going to see AI woefully underutilized at first. Everybody's going to claim that AI is part of their solution. But the power of AI, when harnessed correctly, is going to change the landscape entirely yet again. Your key to effective AI may well be an adaptive continuous integration process. Have you given that any thought? The idea that a rigid process that we use today may change as our code starts to change without our interaction. We're going to be talking more about CI today in its current state. All of this, though, to say, to keep up, your release cycle needs to be highly efficient. So we're talking about the when and how you distribute updates to your product. So let's talk a little bit about release management. What defines release management? I mean, after all, the term release is pretty loaded these days. Software products are typically in an ongoing state of development now. They're, quote, complete, but they're never finished. And that cycle of development, test, and release, it's becoming more complex, especially as the platforms that software is released on are in a constant state of evolution too. I mentioned Kubernetes. If you compare the announcements from AWS reInvent last week with some of the other announcements that are coming out from other cloud platforms, and you look at what you can do native, there's so many different things that are happening at such a high rate of speed. It's not easy to keep up. So one of the ways that GitLab focuses on this is by building the 20% of our solution that can achieve 80% of the results. It's that focus all the time. And it's code and feature complete, but it's never, quote unquote, finished. We also want to make sure releases ship on time and with minimal disruptions to users, right? That's critical. Overseeing that process from development and testing through to deployment, making sure the handoffs from different teams is smooth, it all helps us prevent those bottlenecks and delays that run up to a release. And in more and more of my conversations on a daily basis, people are expecting zero downtime environments. They don't want to see maintenance windows anymore. The online world needs to be accessible 24/7. So back to where we started this conversation on this slide, how do we define release management? For today, we'll call it the practice of planning, managing, and controlling software delivery throughout the entire software development lifecycle. It is not and shouldn't be a final checkpoint before release, because at that point, it may be too late to fix things. What it should be is in practice throughout the whole process, from creating code all the way through to deployment. If you've been to the GitLab website, you've probably seen this icon set before. And this is what we tend to refer to as the GitLab workflow. And I tend to talk about each icon and how there's cycle times associated with planning, creating, and verifying. And the red arrows between them indicate a shift between those stages. And that is one of those areas where we can start to look for gaps and we can look for delays. But in this context, we're talking about release management. We're talking about that whole cycle. Well, what's changing in release management? The cycle used to be more linear. It looks like this, but there's considerable time set aside for planning, typically, distinct from the rest of development. Now, with continuous deployment, code's deployed as soon as it's complete, which affects the release cycle. So, for example, this workflow that I'm showing you, what I'd love to do with these pictures is to start drawing feedback loops from the end. Draw lines back in the cycle from, say, the verify stage back to create, or configure to package, or monitor to verify. Those kind of things. The feedback loops that we're putting in place here, we're trying to shrink those as much as possible. I'd also like to make this whole thing kind of a loop, because the cycle isn't linear like it's depicted here. Hey, look at that, an infinite loop. I got what I wanted. You've likely seen a version of this image before in relation to DevOps conversations. We're doing more releases more frequently. You know that. Planning time overlaps with development in every case in order for us to release more frequently. If you take only one thing away from today, let it be this. Don't let your planning process idle your development teams. The cycle doesn't end with a release. Ops and monitoring are another piece of this. They're now included, as is user feedback, incident reports, vulnerability monitoring, usage statistics. It should all be factored into planning your next release. And the result is this endless cycle with significant overlaps, and the role of a release manager has to change as a consequence. Release management is now more focused on operations than ever before. Release management doesn't just work on the part of development and QA, but it's also operations, customer success, support, sales, product management, security, marketing, the list goes on and on. We're trying to facilitate a feedback loop that turns your users' experiences into fixes and new features. So a quick story to illustrate this. A Tesla end user made a feature request to Elon Musk via Twitter about a year ago. You may have read about it. And that change was implemented within 6 days. So not only did that make headlines, but it changed people's expectations yet again. So whereas before a release manager may have relied on a report from QA to assess the quality of a release, test automation now has to take over for us to achieve something like that. I spent 10 years myself in QA in a windowless lab, no less, and we held up a lot of releases. Now, I'm not proud of that. Part of me is, but the process for building good software left a lot to be desired 10 years ago, right? That ball would come over the wall after being worked on for a month, and my first goal was to swing the bat and hit the ball back over to development because they just didn't get it right. So I'm glad those days are gone. Release management is dictating quality gates between development and production, not between development and QA. And that quality threshold now needs to be built into automated tests. Because that release cycle is more cyclical, it's no longer sufficient to perform tests on new code near the end before we deploy. That continuous delivery model means code must always be in a state that's ready for deployment. So you need to test that new code all the time, which is, we don't want to get confused here with that continuous delivery and continuous deployment concept. Continuous deployment is where there's typically no final manual checkpoint before the code goes into an environment. By the way, Gartner agrees with us on all this. They're saying by 2020, 50% of global enterprises will have implemented at least one application release automation solution, up from less than 15% today. So that whole automated delivery, automated deploy thing, it just doesn't have enough traction in the market today for global enterprises. But there's a lot of efforts toward it. So let's start with the coding side, or Git, right? We are GitLab. You don't want a developer to have a local branch on their computer, which is a day, a week, a month out of date with the central repository, and we do run into that. That is the road to merge conflict land, right? Merge conflict land is not a fun place, especially as you near a release, but it is a very real place. So ironically, I was on a call just this past week with a client who insisted on having out-of-date copies of their repositories versus looking at newer technologies and strategies that are available to help eliminate all these merge conflicts. But don't look for better ways to resolve merge conflicts. Look for ways to eliminate them with new ways of working. Don't accept the status quo. As a follow-on, then, you would ideally have developers checking new code continuously so you can run builds automatically and continuously perform tests on each and every commit. You just don't want to be slowed down by testing. Manual tests are time-consuming. They should be avoided as much as possible. Otherwise, by the time results are returned, your developers have moved on to other tasks. So context switching is really bad for workflow when you have to stop, go back, and address a fix from something that happened a while ago. A guy named Gerald Weinberg proved this by showing that every context switch costs developers about 20% of their productivity. If you are part of multiple projects and say you've got these delayed testing functions, test issues and defects begin to appear in each project, the context switching can actually rob you of 60 to 80% of your productivity. That 20% compounds. It's an amazing statistic if you let it sink in. Losing over 50% of someone's productivity because of the way we test. We need results from testing fast. in order to keep that from happening. Now, if you're in healthcare, let me talk to you for a moment. While banks are leading the way in technology right now, in my conversations, and this is my personal experience, healthcare and insurance is where I run into the most manual testing and the most legacy workflows. Let me challenge you, if you're in those spaces, to reach for new efficiencies in automation in the year ahead. When we talk about continuous automated testing, like continuous integration, right? It ensures that quality is consistent throughout without slowing us down, without those context switching issues. Leveraging some robust CI functionality and auto scaling functionality keeps people in their workflow and keeps us from waiting too long on things. There's three important things for us to consider here as we talk about continuous automated testing. First of all, test every commit. If something breaks, it's obvious where the problem lies and it can be fixed far more easily, right? So the idea of minimally viable code, where we're checking in smaller and smaller code chunks, it's just one of those things where the less code we commit at a time and the more testing we do, the less resolution pain we have. Secondly, fix as you go instead of backtracking later. This gets back to that context switching thing. If I fix a defect that popped out in a very short period of time versus pushing it out into, say, the next sprint or another day even, my speed to resolution is dramatically quicker. And thirdly, using learnings from failures to improve your existing tests. We talked a little bit about feedback loops. Amplify that. The feedback loop that is part of the output of tests feeding back into the design of tests is one that we need to take advantage of. Our data shows about 75% of companies are doing automated testing. If you aren't, your competitors most certainly are. And that doesn't just mean large automated UI tests on legacy platforms. Check out Heroku test packs if you haven't. It's Heroku, Heroku. We use them in our auto DevOps functionality for effective, fast baseline testing. It's a good starting point. Now, automating that release process is the next step. Continuous delivery takes that build that passed all your tests and it deploys it to an environment like staging. That means your staging environment is always reflective of the latest changes to a branch. And you can easily share previews with the wider team and stakeholders for feedback. You know, this is great. We've got a lot more stakeholders involved these days as this continuous loop draws us together and we don't have those separations of the planning state and the development state and the operations. So it really helps us make sure we're building the right things before we put it in front of a customer. And, you know, it's one of those things that we've had a lot of time to experience. In fact, a friend of mine, Colin, would build some really, really great apps, but it was always difficult to get that in front of the wider team and the stakeholders for feedback because we didn't have this kind of environment in place. So, you know, if I'd had that in place, I could have seen Colin's excellent code popped up in front of me as he was building it and given him feedback along the way. The continuous deployment piece now would remove that last manual checkpoint before pushing builds to production. It just does so once that build is complete and it passes all the tests in the pipeline. Okay, that's the difference again. The most important advantage here is that the feedback loop is as short as possible. Notice I keep coming back to that. For example, let's say you've got a prospect that reports a critical bug that's preventing them from signing the contract. So a developer can fix that issue with the changes shortly after the issue is logged, you know, back to the Elon Musk example. That is a beautiful and powerful thing. It reduces the amount of time your product sits on a shelf waiting to be deployed because these systems are in place. The cycle from development to testing to deployment is highly efficient. It frees up your team to focus on creating value and not just do repetitive tasks. by the way, it also helps you with an example like this. So I spoke with a CIO not long ago that told me he had sponsored a $1 million investment in a feature for their website. But because their processes didn't have a continuous deploy and it didn't have notifications involved where the way it should have, that code that was written remained idle for nearly 11 months on the production server because no one flipped the toggle. This stuff happens in real life. We build all this stuff and it doesn't go anywhere. Imagine the lost ROI on $1 million investment sitting idle for that kind of time. So continuous delivery, continuous deployment, when done correctly, eliminates that kind of woes. But it's not easy, is it? We can talk about this all we want, but it takes effort. There's a lot of challenges. There's a lot of barriers we encounter whenever we begin conversations of this type. And it's often a radical shift in how things have historically been done. It's never as easy as we'd like. That is a glowing change sign. And notice it's red, right? Because change is often painful. If you're not routinely checking in and testing new code today, you're going to face some significant culture change. Roles and responsibilities are shifting. Some established employees will protest out of the change of fear alone. I've seen that many times, and many times coaching can help. But a lack of adaptability here is causing a lot of organizations to stop and assess all their strategies. And so, change is becoming a really important piece of this puzzle. So another change to this whole conversation is, instead of deploying and hoping for the best, which a lot of organizations have done in the past, we're testing and doing some release automation. It's requiring a more proactive approach, including writing tests up front, which can seem really intimidating, right? We don't necessarily know everything that's going to happen ahead of time, post-implementation, but it's a critical piece. CI adoption also may require learning how to use new tools that'll ultimately make life easier, but it's going to ask for investment in training up front, or it may mean that in order to gain those new efficiencies, we have to convert existing systems over to something new. Investing time in a conversion project like that can make gains for every commit going forward, but it's painful at the time. So for instance, I'll encourage you to check out the GitLab blog post from about the July timeframe about Ticketmaster. They reduced their build pipeline times from 2 hours to 8 minutes after switching to GitLab. So for them, there was a conversion process in place, but it was absolutely worth the investment for them in the long term. Now, it's going to take some time to win people over, but if you introduce this practice to even one small project, the outcome of a more streamlined development process, less downtime or more results, they make the change easier to sell to other teams. So what other challenges do we run into? Well, there's a lot of complexity. Things like cross-project dependencies, lots of code branching and different code branching strategies, inflexible existing processes, legacy systems, monolithic apps, level of modularity in your software. These are all things that complexify your projects. And they all become potential obstacles to the adoption of automation. So how do you overcome those challenges? Well, first and foremost, talk about them. Have candid conversations. For example, if you have legacy software systems, you're not off the hook. For CI, you can use CI and automated pipelines to build and test files before deployments, especially on headless systems, because a lot of that can be scripted. And an example would be to, say, build a war file before deploying it to WebSphere or something like that. Don't exempt your legacy software systems from new efficiencies that are available. Another example, if you're used to remote repos and only occasional code pushes, look into those updated branching strategies that enable a more continuous process. The longer code sits without being merged, the more complex our testing becomes and the longer our feedback cycles become. It's that frequent running of automated tests that really pays off. It helps us avoid what we earlier called merge conflict land. And then how do we scale this stuff? I think of Black Friday whenever I think of scaling, and it's ironic that it was just a couple of weeks ago here. What would your current solution have to do to survive a Black Friday event? What about your development environments? If you change to this style of working, if you scale your build and test pipelines dramatically as a part of a CI overhaul, can your existing infrastructure even support that? Well, containers certainly help us here. And if you've gotten involved with Kubernetes and with auto-scaling runners, and if you've looked into auto-scaling functions in the cloud, there's some things out there that help us simplify that process of testing and deploying software. You can package that application code and its dependencies into a single portable container, and it's more easily moved through that development lifecycle. The containers also facilitate CI and delivery as well by providing that secure, efficient application environment that we can easily scale up or down. Containers just plain scale a lot easier than bare metal or virtual environments. And once they're configured, they allow you to approximate a production environment, right? We talked a little bit about staging or review environments. Development teams can test the impact of their changes safely and really well mimic what's going to happen in production. Now, for DevOps teams, it means that developers can find and fix errors a lot faster. We're reducing dependencies on operations and effectively speeding up the development lifecycle. It also moves the needle for security by checking for vulnerabilities on each code commit. GitLab has some high focus on security for the year ahead, and automating security processes means less manual interaction with your pipelines and with your failures as they occur in the build pipeline due to vulnerabilities, for instance. And that reduces context switching within that space. So keep an eye on what we're bringing to the table in the months to come on this. We want things to become more automated in the security space. Ultimately, what it comes down to is if you're adopting a container-based application development process, you can more reliably practice continuous integration and continuous delivery. So the containers are making it possible to build one version of an application that's easily deployed to multiple types of environments. The environments developers and QA leverage is exactly what you see. So testing, staging, production, it's all the same stuff. And code can be shipped faster when packaged in a container because errors and bugs were caught earlier in the process. Whenever new changes are introduced to the code, you simply update the container image, spin up a new container, versus uninstalling an old version and replacing it with a new one, or spinning up a new environment that's based on a legacy model of some kind. It's just simply faster. When applications are built as containers and they run on an integrated continuous integration server, developers can automatically test their code in a production-like environment, closing that gap between dev and operations. And with cloud-native environments, scaling containers is becoming easier than ever because those auto-scaling options are coming into play. We no longer have to worry about all those compute issues, and hooray for that. So when we talk about integrated CI/CD, we're talking about working in a single environment that does all the things that we talked about today. Now, from a tooling perspective, that means no tool is an island, because islands at some point are just that. They're islands. And ironically, some islands are barrier islands. I find the naming interesting. So when we are talking about continuous integration and delivery, and we integrate that with the development tools, like GitLab. Of course, we got to mention that because it's who we are, it's what we do. It's one of our fundamental offerings, right? It's possible to automatically trigger a CI build every time a developer commits new code, run the tests in parallel, spin up and destroy some ephemeral or temporary production environments to see the changes live. This can all be done and seen from a single browser window. And that's a key to efficiency. We're not hopping between tools, screens, environments, trying to manage and maintain plugins. It's just it can become quite a mess, right? If you look on the screen, this is pretty clear, box by box, how things are plugged together. In reality, it probably looks like that picture from a few slides ago with all the different routes climbing over each other. If you are a user of GitLab today and you're familiar with merge requests, I tend to call those the center of our universe for software development because of the connection, right? One screen to rule them all, if you will. The connection between code commits, build results, test metrics, review environments, all that stuff comes together, pipeline results. It's in one place. And that's the whole idea. How do we bring everything together in one place? Now, when we couple CICD with containers, we also have the potential to fully automate the build, test, and deploy stages throughout the whole SDLC. We're making it easier and faster for developers to get their code reviewed and ensure that it's production ready. So, how do we do that? I want to give you an idea what it looks like in GitLab. And so what I'm going to show you is how we can spin up a new project and leverage our auto DevOps functionality to actually spin up CI quickly without having to know everything about it. And so what I'm going to do is I'm going to introduce you to a new screen here. And I'm going to create a new project. So welcome to the GitLab UI. I'm going to create a new project in here. And I'm just going to import this project from an existing project that I have available. And we will call this AutoDev1. And we'll just create this project real quick. What it's going to do is import an existing project that I have. Now, before I get going, there's one thing I do need to do. In my environment, I have to turn on Auto DevOps. Now, ordinarily, I like to have this enabled by default, but in the environment we're in today, I don't have that, so I have to turn that on. And we'll tell it the domain. Now, what's going to happen here is everything that I've set up in this environment is just a little Ruby code, basically. I imported some gem files, a rake file, a server file, and this server file is what I'm going to change real quick. So I know in this environment, this is my Hello World, basically, app. I'm going to edit this code real quick. I just want to change the background color. So it's typically gray. Let me change it to navy. Okay. Now, I have not set up anything as it relates to pipelines. I have not created anything. There is no YAML file in here. We use a GitLab CI YAML file to orchestrate our builds and our pipelines. I've done none of that. I'm just going to simply commit this change. And some of you are gasping in horror because I'm committing it to the master, but I'm going to do it anyway. Now, if I go to my CI/CD, notice it says Auto DevOps here, and there's various stages that are running. Let me click into this. Now, a couple of things are happening. I committed that change, and right away, we have a build running. I also have code quality, testing, and an automatic deploy function. Now, if I had used a merge request for this and set that up the way that I should have for review apps, the reality is I would have not deployed to production, but to a staging environment. Those environments don't exist yet, by the way. I could go to my Kubernetes dashboard and see there's no container for this right now. What's happening in the background is we're using Heroku-ish to take a look and say, well, what kind of code is this? Do we recognize it? Oh, in this case, it's Ruby. We do recognize it. Let's go ahead and build this code, which it did, and it succeeded. Let me go back a minute. And once it succeeds on the build side, then it runs a code quality analysis and a Heroku test pack. I mentioned that earlier. So it's running basic tests on the application itself. Once it gets to production, so these have passed as well. Once it gets to production, it's actually going to spin up an environment automatically in my Kubernetes cluster, which is on the Google Cloud platform. So when this spins up, this is automating that functionality for me. Now, we've only been talking for a couple of minutes about this. I created a project, made a change. It will be now deployed to production. And I don't know, I didn't watch the clock when we started, but it's just been a few minutes and it's now active in production. Okay, so here's my production environment and here's my pod that was spun up in Kubernetes. Okay, so now if I click on this to open it, I believe it should be ready. There it is. You know, I got to change that navy background. I am not a fan of that, but you get the idea, right? I am now spun up in a production environment, and we did all that with Auto DevOps and GitLab. This is a very simple pipeline. It's a very simple process. It just has those 3 stages with an auto deploy at the end. Let me paint one other quick picture for you on what a pipeline may look like as it becomes more complex. So that's out of the box. That's Auto DevOps. Notice the Auto DevOps label is missing here because I've built a little more complex environment. When we talked about jobs and we talked about running things in different environments, we started with a build process, but the file that I created to specify things pulls a series of images out, a series of container images, and runs tests against my code in parallel. So all these tests run in parallel. I've seen this for GitLab.com, and you know, I don't remember the exact number of some 25 or 50 different test jobs running in parallel. This can get really complex. And so, you know, in this case, you see I've got a lot of green lights. And if something went wrong in here, let's say that my coveralls test is critically important, it could fail the whole pipeline. If something went wrong and it was not as critical, so let's say it was my static analysis and I let some of that slide right now, which you shouldn't, right? That may be allowed to fail in the file that I put together. So there's a lot of different options for how things run and where they go. And of course, a lot of different statuses that can come back, artifacts that are returned with this, etc. But this is just a glimpse into what it looks like when you make that commit in the GitLab environment and everything's running together. And of course, the information about these pipeline runs, as well as the code commits, can be seen in our merge requests.
Joel, can I interrupt you quickly?
Yes,
we just had a question that would be good to answer here and now. Kian, I'm sorry if I'm pronouncing that wrong, asked, what happens if a step in the pipeline fails, such as the code equality or test case?
Okay, Joshua, do you want to take that or you want me to grab it?
Sure, yeah, I can take it. So you actually have a number of options for handling how you want that to behave. By default, if a test case fails, then the pipeline will not move forward. So we'll continue to execute the rest of the jobs in the stage. So for example, the test stage, we'll go ahead and continue to run those to make sure and alert you in case there's any additional problems with other test cases, but we're not going to go ahead and proceed to the documentation or the staging and other deployment jobs. But as Joe mentioned earlier, you can, if you want to, mark jobs as essentially okay to fail. And so if you're aware it's flaky or if it's not that important, you can absolutely set that flag, and then the pipeline will continue. Joel?
Okay, great. Yeah, Joel and I have been chatting, and he's told me he's ready to move on to questions. So we did have one come up during the presentation earlier. Alvi asked, why does the healthcare vertical lend itself to the most legacy systems in DevOps?
Yeah, and it's again, this is my experience based on the calls. So I spend my time each week speaking with customers, and on any given week, there's anywhere from 10 to 15 customers that I will have a conversation with. And we've just noticed a trend in the conversations where a lot of the larger systems, especially those with more regulation, and interestingly, if you talk to folks at some of the biggest banks, or if you just watch the news feeds, you'll see a lot of technology from the banking sector, for instance, is leading the way. and they're really doing some amazing things to try to stave off that disruption that Mark Andreessen talked about. Because, you know, the likes of a Chase or Citibank or something like that, for instance, has so many different offerings, right? And they need to keep on their game to defend against the likes of something like, say, SoFi, right? Which has a targeted audience and it goes after one thing, or Lending Tree, for instance, and they go after one sector of the banking. So those are really disruptive things. When we talk to folks on the insurance and especially the healthcare sides, it's not that we don't see efforts being made. I don't mean to say anything like that, right? I see a lot of great work being done, but it's where we see the highest percentage of manual testing. And so I don't know that it's necessarily legacy systems so much as legacy test process that I'm running into in those environments. And that's the challenge.
Okay, great. Thanks, Joel. Dinesh asked, is there any special tuning required for the GitLab environment, considering there may be multiple developers using it?
Yeah, so not really. We have recommendations on sizing. And so you can simply, follow those based on the number of developers that you have. And then we have certainly some customization options for, knobs you might want to tweak as far as what services you want to be available and perhaps which ones you don't. But overall, we try and make sure that the defaults are good for everyone. And in fact, we share the same defaults in GitLab.com as well. So typically, we don't see a lot of customization or tweaking or tuning required.
Thanks, Josh. Patrick asked, how do you set up the more advanced steps in the pipeline?
Sure. So how GitLab CI is sort of defined within a project is inside of, as Joel mentioned earlier, a YAML file. And we call it the GitLab CI YAML file. And what you do with that, and thanks, Joel, for showing it here, is it's pretty simple. You can see we, at the top here, have stages that you can define. That's what we saw earlier with that build, test, and documentation, and then the deployment jobs. And then down below, you simply define the jobs that live in those stages. And you can have one or multiple jobs per stage. So you saw earlier that test stage had, I think, like 10 or 15 jobs, and you'll see a number of them in there. And then you can see some options here, like a manual deployment or like allowed to fail and things like that. But really the net of it is there's a script step in each of these jobs, and that is simply shell script. So whatever system you're running this on, we support a wide variety. We'll simply use a shell executor to go ahead and run that script on that system. So if it's, for example, a Docker container, the script will run into the Docker container. If it's running on a shell system, it'll run as a shell as the user the runner is running on. And so I think a lot of flexibility there, in the sense that you can essentially interact with any CLI system that you want. And so, it really provides essentially the capability to do anything you can in your console. You can simply also script and automate the same way in GitLab CI.
Hey, thanks, Josh. A question from Daniel. I see that DevOps works with Kubernetes. Since OpenShift stands on top of Kubernetes, will DevOps also work in an OpenShift environment? Yeah,
so the Cloud Native Computing Foundation, which Kubernetes is a part of, has launched a certification program. And so essentially what this means is that for a wide variety of the ecosystem that is working with Kubernetes, these should all work, right? Because they've been certified to essentially conform to the standard Kubernetes platform. Joel, I think you also have some items here you want to add there as well.
Yeah, I just so interestingly interesting that you asked that question now, because this past week I actually worked with OpenShift, and while there's a recent support for Helm charts and things, which is part of our key to making this work, there are some anomalies there at the moment with their Helm support, and so I think that would be one of the minor barriers to overcome. But other than that, it's definitely on track for those two to play together nicely. So there's one minor issue in the way today, though, that I experienced this past week.
Okay, another question from Patrick. I'm not sure if we did cover this, but he says, I missed the first part of the webinar. How do you set up the servers that run the containers?
Yeah, sure. So in this case, what we've been leveraging for the demonstrations is Kubernetes. And so we have our GitLab runner, which is sort of like the worker bee of our CI system. It can be installed on virtually anything. It's a simple Go binary. But we have it running on Kubernetes using our kind of Kubernetes integration with it. And with that, it can simply auto-scale elastically based on how many jobs you have waiting to run, and run those in Kubernetes on what's called pods, which is kind of like a container runner in the Kubernetes land. But we also can simply run on virtual machines or just kind of bare metal as well. And so you can simply install a runner on, say, AWS EC2 or a VMware machine or what have you, and that will also then go ahead and pick up jobs and run them as well.
Okay, and there was another question from Patrick. Is there a list of supported languages that can be used with auto-deploy?
Yeah, I think we have that documented, but it would be the Heroku-ish build pack list for the languages, but I believe we have that documented in our documentation.
Yeah, it's basically the top 10 most popular programming languages. So if you're looking to Ruby, Python, Go, Node, etc., that's the kind of stuff that's supported.
Okay, great. Enrique wants to know, how is it that we went from an auto DevOps default with the code quality and tests to several personalized tests? Is the tuning mainly done in the GitLab CI YAML?
That's exactly right. So auto DevOps essentially just gives you a default GitLab CI YAML. You don't see it, but it's there. And then what you can do is, if you want to then start to customize it, you can simply go in and add a GitLab CI YAML file, and one of those options in the templates is the Auto DevOps template. And so if you want to sort of start from where you were with Auto DevOps, you can absolutely do that, and then start to make some customizations from there. And Joel's showing you live here how that looks. But you can simply pick a GitLab CI YAML file, and then one of the options is the Auto DevOps template. And then you can then customize from here and use this as a jumping off point if you'd like to sort of modify from there.
Okay, Enrique asked, are any of these repos available to fork?
Yeah, absolutely. So we have a pretty wide range of examples and samples. So all the templates are actually, that you see here, are contained in the repo, and so you can go ahead and browse through those. We also have sample projects that are available in a variety of languages. And so you can kind of browse through all of those things, from templates for deploying to various cloud providers, to templates for building various languages, to testing mobile applications. We have a wide variety of sort of best practices and examples to work from.
Yeah, and the examples I'm working from today, you may find those as minimal Ruby app or something like that. There's a series of them like that are out there, and that's where this started.
Okay, and another audience member asked, my company has our data in AWS. We are trying to use your auto DevOps as you have demoed, except using AWS rather than Google Cloud. Could you explain more or point us to a resource for deploying from GitLab to AWS using Kubernetes, especially for review apps? Your review apps is a powerful feature we are trying to get working.
Yeah, definitely agree that review apps is really, really fantastic feature that can transform a lot of the sort of process of working together on, say, a merge request. Auto DevOps on the deployment side does expect Kubernetes, but all the earlier steps do not. So the generation of the container, if it's not there, the generation of the Helm chart, if it's not there, those don't require Kubernetes. But once, neither does the test cases, but once you get to deploying it, those do. But we do have a great number of examples, CI templates for deploying to like EC2 and things like that. And so I think those leverage the AWS CLI, for example, and you could perhaps go through and look at those to sort of swap the Kubernetes deployment over to, say, the AWS EC2 side of things.
And I think that's the important thing to distinguish, right? It's when we're talking Amazon today, it's mostly EC2 kind of conversations because they just announced their support for Kubernetes at reInvent in the past week or so. And so we're tracking with them, though, to mirror their deployment of Kubernetes and have an offering that's associated with that coming up in the new year.
Yeah, and we also have plenty of folks actually running Kubernetes manually or quote unquote the hard way on AWS today, and that works great as well. But yeah, definitely looking forward to sort of the managed Kubernetes offering on AWS. That's going to be really exciting.
Okay, this is probably a question for you, Joel. In your opinion, what is the largest hurdle that you see occurring within enterprises who are trying to develop a plan to move forward with modernizing their development processes to become more agile and reducing the time it takes to move from idea to production?
Wow, what a great question. And, my answer is going to be, I spent a lot of time doing agile transformations in the past, right? When we were focusing on just the front end of the development process more so than the deployment side of things. The reality is it's still a transformative effort, and transformation requires change, and change requires buy-in. And so ultimately, the biggest issue I see is a lot of people just wanting to do their own things without thinking about the larger impact on the enterprise. And so without an executive sponsor of some kind, that is one of the biggest barriers that I see. You have to have a buy-in there. And I think the second thing is pretty related, is that executive buy-in needs to leverage the input from the teams, right? The teams are living in their environments every day. There's going to be a natural migration to the environments that people want to use. So the more that the executive direction and backing of the plans aligns to what the developers want to use, the better off everybody is going to be as that transformation occurs. So it's not necessarily a tooling thing per se. While that can make your transition easier, it has to start with the right advocates and the right cooperation between all levels of the organization.
Great, thanks. Marco asks, we are currently using Jenkins for CICD. Where would you see limitations to what you showed us to Jenkins?
Well, I can start on this. I don't know if Joshua's got anything to add, but Jenkins does a lot of things well, and I've been a legacy Jenkins user for a lot of years. I think what we're starting to see in the Jenkins world is a couple of things. One is from the scalability perspective. It just doesn't scale well. I can't tell you how many conversations I've been on where we've got 6 different individual servers running under 6 people's desks, right? That concept doesn't scale well when we're talking about running thousands of pipelines at once, and so that idea is a problem. Also, just from the perspective of the coding required, the integrations required, you can't quite wring the efficiencies out of it. Now, I mentioned Ticketmaster earlier. Their example is moving from Jenkins off, and so from an efficiencies perspective, we're seeing that when you've got large pipelines, we certainly can run them faster. And then from a maintenance perspective, because of the modularity of how we do things, it's just a lot easier to maintain. All those plugins over time, it's amazing the things that can go wrong and the amount of time we can spend doing the maintenance. So that's some of the distinct advantages that I've seen.
Yeah, just I think to echo some of what Joe was saying, what we have seen is and challenge with the Jenkins side is managing some of the plugins, and especially in a more of a centralized manner, can be problematic and can ultimately cost a fair amount of effort, and in some cases challenges as the number of plugins grows and the dependency web sort of gets more complicated. And then, kind of on the GitLab side, what we've tried to do is really make this as decentralized as possible, and pass along as much ability for individual developers to manage this process. And so to try and not require, say, the tools, infrastructure, or build, or kind of whatever team that kind of owns and operates this infrastructure, to really not have to require them. And so while certainly GitLab does support working from a common pool of shared runner infrastructure, that isn't required. And a lot of companies just decide to let the development teams handle it themselves. And with GitLab, you can install the runner and connect it up to your project as sort of a per project runner. That takes all of a minute or two. So for example, if you have some special requirements, maybe you're the iOS development team and you need to have an Xcode machine, a Mac, attached with a couple iOS, iPhone hardware for doing testing, rather than having the infrastructure team manage that perhaps in their server room, you can simply find a laptop in the corner that might not be used anymore, plug it in, turn it on, install a runner, and away you go. And you're able to get this task done in 5 or 10 minutes, as opposed to trying to, to negotiate and purchase and provision this with sort of the central team. And so that's some other areas that we've seen really help to unlock a lot of productivity to kind of decentralize the ability to manage this and push it down to the development teams where they really know what they need to do and how to best do it.
Okay, while we're talking about Jenkins, I'll ask Mike's question. He says, one benefit we saw was the sort of dashboarding we got about general code quality trends, the number of tests, etc. Does GitLab plan to grow some of that functionality as well, or is there some external tool you'd recommend to fill that role instead?
Yeah, so we definitely have a number of ideas that we're working on there. We do have some pretty basic charts today available for each project that show how long a pipeline ran, how often it failed. But we're also trying to improve this as well to give you a little better reporting there around perhaps flaky tests or tests that are flapping, as well as the general trends of some of these things. So like you saw, for example, code quality there, directly on the merge request page, able to show you, whether a given merge would increase or decrease code quality and what the findings were. And we're working to expand that kind of model out to a number of other areas, and then not just show it for a given merge request, but also try and chart that progress over time on, say, like the master branch, to give you a better idea of how trends and whether you're working towards and your larger goals to perhaps test coverage about a certain percentage, or meet certain performance gates over time and things like that. So definitely working on adding a number of different reporting features to help capture these trends as well.
Okay, thanks, Josh. Just to note that we are running out of time. So if you have submitted a question and we don't get to it today, we will get back to you afterwards offline. So don't be alarmed if we don't get to it today. But I'll ask William's questions next. Do you know of any tools that will help review native mobile applications?
Certainly there's a ecosystem of tools that can help do this. We don't have our review app right now is kind of tailored towards more of the web style review. So it's great for any kind of web properties or API tests and things like that, where they're kind of hitting a backend web server. And of course, also front end as well on the website itself. We haven't expanded it into some of the mobile applications, but this is a really interesting area to kind of consider to help either integrate or perhaps see if we can adapt it to better provide a review application in that sense as well. Of course, you can always go ahead and check out the repo and build it, or just simply have a stage that builds a mobile application itself and then download it and install it are also good options as well with GitLab CI. But not quite as easy as the review application is today for kind of the web properties and API.
Okay, I think we've got time for one last question. So I'll ask the next on the list, which was from Patrick. Does auto deploy depend on using Kubernetes on the server?
Yep, so I think we covered this a little earlier, but so the auditable template for the deploy job that does require Kubernetes, but for the earlier jobs, the build, the testing phases, those do not require Kubernetes. And so you can, those will simply, the ones that require Kubernetes will simply not run in the event you haven't configured Kubernetes in your project.
Okay, great. And with that, we're out of time. I just want to say thanks very much for submitting all of your questions and for staying with us right to the end. So thank you all for joining us today, and thank you to Josh and Joel for the presentation. We will send you the recording afterwards, most likely tomorrow, so keep an eye out for that if there's anything that you want to review on your own time. But otherwise, thank you all for coming and have a great day. Bye for now.